Hey folks, Wolf here with another Unit 2 chemistry screencast. This might be one of the last ones focused on stoichiometry, and in previous episodes we've looked at limiting reactant, theoretical yield, percent yield. Now we'll explore what's left over in a reaction after everything, if the reaction has gone to completion. This is known as the excess reactant. That's the reactant of which we will have leftovers. And the amount remaining is, you guessed it, the excess reactant remaining. I'm going to zoom in on the notes here. I've just kind of snipped this because I figured out I needed a larger blank slab of paper to work on. So I've snipped from the notes and created a bigger tablet to work on. So it says here that the excess reactant is the reactant for which some remains. Imagine if I had 30 slices of bread and 5 slices of cheese. What would be the excess reactant if we were making grilled cheese? Hopefully you just guessed the bread. Second of all, excess reactant remaining is the amount, a specific quantity left over. And the steps provided here are identify the excess reactant. That's the one that's not the limiting reactant, so you can use process of elimination. Determine how much excess reagent the limiting reactant will consume. We'll look at how that sugars out in the math in a second, and then subtract the amount used from the amount given, and that's your excess. Really, a lot of that kind of, I imagine, flies over your head until you look at a specific example. So they give us the example of 79.5 grams of sulfur dioxide. I wrote this down ahead of time. Reacts with 12.5 grams of oxygen gas, that's right here. Determine the excess reactant that will remain unreacted. So we got to do a lot of things. This is the first time I've looked at this in a few hours. So we need to first determine what the limiting reactant is. Then what we got to do is see how much excess will react. Then what we will do, so let's call this 1, let's call this 2. Then what we'll do in 3 is subtract 2 from the amount of excess given. I'll try and leave this here, but I may have to erase it, so be forewarned. I'm going to go with green right now, and let's dive right in. First thing I want to do is figure out what my limiting reactant is. So 79.5 grams SO2. Let's convert that to moles. I get the molar mass ahead of time. So SO2 is 64.07 grams per 1 mole. And then for every 2 moles of sulfur dioxide, we get 2 moles of SO3. Pardon me while I calculate. And I get 1.24 moles of SO3, which is what's theoretically possible from 79.5 grams of sulfur dioxide. Now let's do the same thing with 12.5 grams of oxygen. Convert those grams to moles. Use the ratio from the equation. 1 mole of O2 makes 2 moles of sulfur trioxide. Pardon me while I calculate. And I get 0.781 moles of SO3. Quick test, folks. What is the limiting reactant here? 3, 2, 1. This is my limiting reactant because it makes less sulfur trioxide. Now, I'm going to figure out how much excess will react with my limiting reactant. So here I go. This is step 2. I like the color of that blue, so I'm going to go 12.5 grams of oxygen. I'm going to convert that to moles. Then what I'm going to do is look at the ratio between oxygen and sulfur dioxide by looking at the coefficients. And I recognize that for every 1 mole of O2, I react 2 moles of SO2. And since we're dealing with how much, we're dealing with grams, I'm going to convert that back to grams. This will tell me how many grams of sulfur dioxide actually reacts with my limiting reactant. So 1 mole of, sulfur dioxide weighs, because I did the math ahead, 64.07 grams. Pardon me while I do the math. And I get 128 grams of sulfur dioxide. So that's what will react. And I immediately recognize something is amiss here, because I was only given 79.5 grams sulfur dioxide. In relief, don't know what I did, but the actual answer is 25.0 grams SO2. Okay, so this is what will react. I'm going to subtract this from what I was given to get the excess reactant remaining. So 79.5 grams minus 25.0 grams equals 54.5 grams of sulfur dioxide remain. So folks, to review, in this problem, what I did was I first determined what my limiting reactant was, then determined how much of my excess reactant my limiting reactant would consume in reacting. And once I figured that out, I subtracted that from what I was given to begin with. And that gave me quite a bit of waste in this example. More than half of what I was given did not end up getting used to make sulfur trioxide. I hope that makes sense, and I do want to add that there are multiple ways of solving these, but to me this is the most intuitive. It may not be the fastest, but it's the